there is a vessel which is a frustum, and then which is made by the lower cutting off the lower part of the inverted right circular cone of base radius 72 cm and height 96 cm. So they say that it's come from the largest cone here, and then they say that it's placed on the horizontal table to ensure that the water surface are parallel to the base. And then there's some water inside the depth of the water, so it's 28 cm. So they're talking about the middle layer here is the water, so talking about this region. And then that means the cutting off the lowest part is talking about the bottom cone, inverted cone here. We are going to find the area of wet curve surface. So before we set up the strategy, we need to realize that we are talking about the middle layer curve surface area. To get this layer, our strategy, if we scratch it on a table, then it should be something like this, and then it's come from a larger curve surface area minus the smaller curve surface area. That's our strategy. How can we find out the wet curve surface area of this vessel? And then you should think carefully about that. Should we include the base here? Because it's also wet, it's also contact the water. But however, the wording curved, the base here is flat, it's not curved. The curved surface, we are talking about the lateral surface next to it here. So basically the curved surface area, we're just talking about the parts of this sector. And then our strategy is to use the complete sector to minus our smaller sector here. In order to do this, the formula is pi RL. But however, we don't know what is R and L here. So our first mission is to find out what's the base radius of this two triangle and also what's the height. Whenever you find this inverted cone, then you should draw three cones separately because they all repeated each other. Then it's difficult to realize. So we have the largest one, which is similar to the middle one, which is similar to the smallest one. You should label it like this in your draft, and then we are going to write down all the information. For the largest one, we have the full detail. We have the base radius and we have the height. So we mark it down first. The base radius 72 while the height is 96. And then after that, we have the smallest one, just 96 cm minus 60 cm. We know the difference here is 36. So the height here is 36. And the middle height, the middle cone, we just add 28 on top of 36. So we get the height of the middle one is 64. Basically, it's very easy for us to get the radius already. It's because the length, the base radius, and the height have the certain ratio. So if you consider this is capital R, this is small r, you may just compare these two first. They are similar, which means that their length ratio are the same. So 72 to 96 should also equal to the middle one, the base radius, to the height, capital R, to 64. Or you may write 72 towards R is equal to 96 to 64. You may say the radius to radius should equal to height here. Either this equation will give you exactly the same result. So we just focus on the first trial. And then R is equal to 64 times 72 over 96. Therefore, the base radius is 48 here. Similar reason, this time we compare the largest cone with the smallest cone. So therefore, we can draw the conclusion that 72 to 96 radius to height should equal to radius to height here. So R to 36. Then we get 27. We have 48 and also 27. Now it's very close to our answer. But finally what is needed is L, the slant height. We are going to use the Pythagoras theorem. This L is the base radius square plus height square and then square rooted. We mark it like this and then we write down L1 is equal to square root 48 square plus 64 square. But again, it is 3 to 4 to 5, so we know that it's 16 times 5, so it's 80. Also, we get L2. Another slant height is equal to square root 27 square plus 36 square by Pythagoras theorem. 3 to 4 to 5, so it should be 45 here. We finished all the preparation work and we have all the data we need. Now we are going to use our original strategy to find out the red curved surface. Is equal to original this one pi r L1 minus the smaller one pi r L. So the base radius of this cone is 48. The slant height of this cone is 80. And then minus the smaller radius is 27. The slant height here is 45. We get 2625 pi cm square. Because they say in terms of pi, so you just keep pi here is fine. It's relatively time consuming, but it is the most difficult part of this questions already. And then in part B, it's even easier than part A. They ask about the volume of water in vessel. Is that greater than this amount? So we are going to compare the volume with this. To get the water volume, we are talking about the middle fluxton volume. So the method is we use the middle cone, subtract the smallest cone. That's our strategy. And then the volume, we already have the base radius here, we have the height. We have 27, we have the height is 36. So it's very straightforward. The volume is just equal to 1 over 3 pi radius square times the height of the cone minus another cone. We get 40404 times of pi. Then because this one without pi, so we have to use calculator times 3.14 something. Then we find that it's 126,933 approximate correct to nearest integer cm power 3. And then we need to compare with this one. However, this one is meters power 3 and this one is cm power 3. They are not the same unit. So our target is to change this units to meter. In primary school, we know that 1 meter representing 100 cm. Therefore, whenever you find cm is represent 1 divided by 100 meter. It just seems like we solve the equation both are divided by 100. So whenever I find this item cm, I try to give it a bracket and then change it by what we know is 1 divided by 100 meter. So we successfully changed cm in terms of m. Afterward, we just follow our index law. 1 over 100 power 3 we give 1 over million. And then m power 3 is give m power 3 here. So it's 0.126933 m power 3. And then with the same units, we can compare with this. This is larger than 0.1. Larger than 0.1 meter cube. So that's why you say that agree that